So this problem, I'm given the derivative, and I am told to find all the extrema and the inflection points. But I'm allowed to use my calculator on this problem, and I'm going to use it to the max. So I know that I'm going to have critical points. First of all, I know this is a polynomial, so it's not going to have any areas where it's not differentiable. And I'm going to have critical points at 1, 2, and 4. I put it into my calculator. I'm going to go zoom 6. I'm going to graph the guy. Well, I want to look at it a little bit more carefully here, because like between 1 and 2 there, it looks a little bit sketchy. It looks almost kind of flat. So let's go window, and I'll make my x minimum, I'll make it -2, and I'll make my x maximum 6, just getting a little bit of space there. And I'm going to make my y values, I want to zoom in on that a little bit. So I want to look at my y's, like say from -4 to 4, and see what that looks like. So I'm going to graph it. Okay, so I can kind of see that at 1, 2, 3, that I do have zeros here at 1, 2, and 4. And this is my derivative function, remember? So I can see that at 1, my derivative function is going from positive to positive. It's just a touch right there. So that is not going to be, that's no extrema. Now, at x equals 2, my derivative goes from positive to negative. So that means I'm going from positive to negative. That means I'm going to have a maximum at 2. And at 4, right there, my derivative is going from negative to positive. So I'm going from negative slope to a positive slope. I'm going to have a minimum there in my function. So far I know that I'm going to have a maximum at 2 and a minimum at 4, and that at 1, even though it was a 0 here, is not going to be an extrema. But now I'd like to find my second derivative. Or rather, I'd rather find where is my second derivative equal to 0. So I got a choice. I can either do the product rule on this whole monster thing right here, which will probably take me 30 minutes, or I can go to my calculator, and I'm going to do this. I'm going to graph it. So I'm going to go by y equals, and in y2, I'm going to use the function alpha f2. I'm going to use number 3, my end derivative function. That's a function of the calculator. And I want to find the derivative of the function that's in y1. The function that's in y1 is my first derivative. If I find the derivative of that, it's going to be my second derivative. So I want to find the derivative of y1. So I go alpha f4 y1, and I put a comma, and I want to find it for x with respect to x. And I close that out. I'm going to make this upper graph here not show by hitting the equal sign and making it a big equal sign. And now when I go zoom 6, I'm going to have the graph of my second derivative. There it is. There's the graph of my second derivative. And it looks to me like I have 3 zeros on that. And I just want to know whether they're inflection points. Well, they are all inflection points, because at each one of these zeros right here, I'm changing from negative to positive, positive to negative, negative to positive. So I know that I have 3 inflection points. I would like to know what those x values are. Well, second calc, well, what is my 0? I want the first 0. And my left bound, I'm going to make it 0, and it looks like it's like, oh, I don't know. You know what, I might need to expand this a little bit. I'm going to change my window from 0 to 6, and I'm going to make my y's a little bit easier to see too, so I can see the 0. I'll go -5 to 5. Now I'm going to graph it again. Again, this is my derivative. Oh yes, this is much better. So I'm trying to find my zeros. And I'm going to go second, calc, try again. Second, calc, zeros. And my left bound I'm going to make 0. And my right bound I'll make it, well, it looks like it's going to cross right there about 1. So I'm going to make it, I don't know, my right bound 1.1. It's messing me up here. Try again. Second, calc, zeros. My left bound I want to make at 0. Press enter. Good. My right bound, you know what? I'm just going to scroll over here so I can pass the 0 and make sure I don't go too far. That's my right bound. Enter. I don't want to guess. So I have 1, 0 there, an inflection point at y at x equals 1. So I have 1 inflection point at 1. What's my next inflection point? Second, calc, 0. That's a good left bound. Enter. That's a good right bound. Enter. I don't want to guess. I have another one at 1.63. And oh, I got to go second, calc, 0. I want one of them to be, there's my left bound. I can make my right bound 3. I can kind of see, no, my right bound actually 4. Hit enter. And I find that my third one is at 3.67. I'm sorry, I read that incorrectly. It's not 3.67, it's 3.367. 3.36. And those are my inflection points. I know it for a fact because that's the graph of my second derivative. Inflection points happen where there are zeros and where the sign of the second derivative changes from negative to positive. So using the calculator on this problem really made this a whole lot easier.